Good morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about yesterday's topic only, the oblique incidence at a plane of conducting boundary. Oblique incidence at a plane of conducting boundary. In this, there is two polarizations. One is horizontal polarization, and another one is a vertical polarization. Horizontal polarization means the electric field vector perpendicular to the plane of incidence. Vertical polarization means the magnetic field is aligned parallel to the boundary surface. Or otherwise, the magnetic field is perpendicular to the plane of incidence. Perpendicular polarization is also called as a horizontal polarization or also called as E-polarization. In yesterday's class, we find out EI bar, ER bar, HI bar, and HR bar. And there is no any transmission in the conducting medium. E1 bar is equal to 0. Nothing but E2 is equal to 0. Both EI and the ER is equal to the same. EI is equal to ER. Okay. The horizontal polarization. In these equations, one right angle triangle we are assuming, another right angle triangle we are assuming is reflected. We find out EI bar and ER bar. EI bar is equal to EI into e power minus j beta 1 x sine theta I plus z into cos theta I AY bar. Similarly, the HI bar is equal to, the coefficient is the same e power minus j beta something, and there is a ANI bar cross EI bar with AY only. So that function will become EI by the eta 1 cos theta I minus A x bar is a negative and sine theta and AZ bar. That is also you'll get from the right angle triangle itself only. Okay. And ER bar is also ER into e power minus j beta 1 x sine theta r minus z cos theta r into AY bar. HI bar is equal to, we got the function. Then as a medium 2 is a perfect conductor, there will be no transmission because the conductivity is a very high. Intrinsic impedance is equal to 0. If intrinsic impedance is a 0 means transmission coefficient is a 0. So E1 bar is a combination of EI plus ER only. EI plus ER only. So what is that function? EI into e power minus j beta 1 x sine theta I plus ER into e power minus j beta 1 x sine theta r when z is equal to 0 into AY bar. So E1 is equal to. In this equation, the value for all the values of x, ER must be equal to the EI. ER must be equal to the minus EI because EI and the ER is in the opposite directions. At the same time, the phase terms of both the incident and the reflected wave must be the same. Let us see here what they are saying. And these two, the equations, and z is equal to 0, the EI into e power minus j beta 1 x sine theta I and ER is there plus ER into e power minus j beta 1. Here the x sine theta r, x sine theta r whole multiply with AY bar is equal to the 0 here. Because at the z is equal to 0, the function, the right hand side, there is no any transmission. So substitute the EI is equal to, ER is equal to minus EI. ER is equal to minus EI. Following my students. EI into e power minus j beta 1 x sine theta I. Substitute er is equal to minus ei e power minus j beta 1 x sine theta r whole multiply with ay bar is equal to 0. Now equate, bring the function to right side, ay is equal to 0, the ei into e power minus j beta 1 x sine theta I is equal to, ay is already the 0 here, ei into, the minus becomes a plus in the right hand side, minus j beta 1 into x sine theta r. So ei get cancelled. Both are exponential with a negative only. J beta 1 x is also the common. So sine theta I is equal to sine theta r. Means theta I is equal to theta r. Okay, nothing but a Snell's law of reflection. At the same time, the phase terms of both the incident and the reflected wave must be the same. Thus, the required condition is that theta I is equal to theta r, which is called as Snell's law of reflection. Snell's law of reflection. Got it, my students? Then, to take the ER function, take the ER is equal to, what is the ER is equal to? ER is equal to, you see there, in the last class, we derived that ER is equal to, the ER is equal to, ER bar is equal to, ER is a coefficient, e power minus j beta 1, e power minus j beta 1 into x sine theta r, x sine theta r minus z cos theta r into ay bar. Okay, my dear students. Using this, now I am replacing the ER is equal to minus EI. ER is equal to minus EI in this ER bar. So ER bar is equal to minus EI into e power minus j beta 1 x sine theta x sine theta r. Theta r is equal to, according to the Snell's law of reflection, theta r is equal to theta I. Now I am replacing the theta r as theta I minus z into, here also the theta r is there, cos theta I into ay bar. So totally I change the ER bar is equal to in terms of EI and the theta I. EI into e power minus j beta 1 minus z into cos theta into ay. Got it, my students? Next, similarly, the HR bar is also converted into the HR bar is equal. What is the HR bar? We got HR bar is equal to HR into, or not the HR, in terms of E only, EI, ER into, E not into by the cos minus cos theta I into AX bar minus sine theta I into AZ bar, and the exponential is the same, e power minus j beta 1 into x sine theta I. Actually, it is a theta r. Now I am replacing that as EI ER is equal to EI. So these are EI minus EI. Okay. I'm multiplying the minus terms also here, the minus cos theta and minus sin theta and minus Z cos theta I. With the AY bar only, we got the cross product function. So HR we got. Now the total electric field intensity in the medium one, E1 bar can be obtained by adding 12.10.9 and equation the 12.10.9. 10. Okay. The two equations we have to add. E1 is equal to in terms of the EI and ER is also in terms of the EI. The second factor term is there here, minus EI e power minus j beta 1 x. So in these two factors, so here in these two equations, EI is a common, take the EI as a common, e power minus j beta 1 z cos theta, because e power minus j beta 1 x sin theta. Here also e power minus j beta 1 x sin theta is a common. E power minus j beta 1 z cos theta and e power plus j beta 1 z cos theta. What is the e power j beta 1 jx minus e power minus jx by is a cos one. Okay, or the cos function. But e power minus j beta 1 z cos theta is equal to cos beta minus j and plus means cos x plus j sin x on the Euler's rule. So E1 bar is equal to substituting these equations EI into the total function as e power, take the minus as a common, 2 sin beta 1 z cos theta. Minus is a common term. Let us take here the 2j is multiplied here, divided and multiply the 2j and keep the minus. Okay, minus means e power jx minus e power minus jx by 2j, we can call it as minus 2j into sin x. What is the x here? Beta 1z cos theta. And already we have the exponential value is a common term, the e power minus j beta 1z x sin theta I into a by bar. Don't confuse my dear students. It's a lot of equations here, but so within the class, have to complete the uniform plane wave, the conducting boundary. Then we can understood. But in yesterday's class and the today's class, you can combine all the equations and you can recall the equations and substitute the E1 bar is equal to in terms of EI. Okay, so E1 bar is equal to minus 2j EI sin beta 1 z cos theta and e power minus j beta 1 x sin theta into A1. And similarly, the magnetic field, the total magnetic field also, the total magnetic field in the medium one can be obtained by adding the two equations, what we got in the previously. But in terms of EI and the theta, okay, EI and the theta, the H1 bar is equal to HR bar plus HI bar. Okay, after simplifying the equations here also, cos theta and cos beta 1 z cos theta, and it is sin beta 1 into cos theta. Okay, and after getting the E1 bar and the H1 bar, the combination of EI and the ER, and changing the theta as a theta, changing the ER is equal to minus EI. From the equations, following the conclusions can be drawn for perpendicular polarization with oblique incidence. With oblique incidence, let us see here. The y component of E1 bar, that is E1 y, and the x component of H1 bar, that is H1x, representing the standing waves generated in the z direction, which is normal to the boundary. These standing wave patterns can be recognized in the terms of sine beta z and cos beta z, where beta z is equal to beta 1 cos theta I. It is a phase in the z direction in the medium. And we'll get E1x and the lambda 1x. Lambda is a 2 pi by beta. The beta is equal to 2 pi by the lambda. And this function, the beta 1 sine theta I, as a W by beta is a V1. The V is equal to W by beta 1. And the lambda 1 is equal to 2 pi by the beta 1. We know these are equations. In the x direction, E1y and the H1x are in the in phase with respect to the time and the space. There's a phase velocity in x direction. The beta 1 is given by V1x is equal to W by beta 1x. That beta 1x is a beta 1 sine theta. Beta 1 sine theta. And the lambda is also the beta 1 sine theta only. Glad we can take the V1 as omega beta 1 and V2 is omega 2 and so on. Okay. The amplitude of the wave varies in z in x direction, and hence the wave propagating that x direction is a non-uniform plane. Understood, my students? Finally, we got the conclusion, the velocity and the wavelength. The velocity we know omega by the beta 1, and wavelength is omega. Wavelength is 2 pi by the beta. Then go for the next one, horizontal polarization we completed and the vertical polarization. Vertical polarization here, what is the vertical polarization saying? That when the magnetic field is aligned parallel to the top of the boundary surface, or otherwise perpendicular to the top of the incident beam. Magnetic field vector is perpendicular to the plane of incidence, while the electric field is aligned parallel to the plane of incidence, then this is called as vertical polarization. Vertical polarization. Consider the plane wave is incident obliquely at the interface between the perfect dielectric and perfect conductor. The dot line shows perfect conductor, and the left-hand side we can call it as a dielectric. As shown in the figure, with the electric field vector EI bar parallel to the top of the plane of incidence. EI is parallel means vertical. EI is perpendicular means horizontal polarization. When we consider only the electric field is parallel to the top of the plane of incidence. Magnetic field is perpendicular to the plane of incidence. Okay. So EI is parallel to the plane of incidence. It is also called as a parallel polarization or H polarization. H polarization means perpendicular to the incidence. E polarization means perpendicular to the incidence. When we can call it as the electric field, comparing this vertical polarization and the horizontal polarization. For the incidence beam, electrical polarization, electric field is perpendicular means that is called as perpendicular polarization. In the vertical polarization or the H polarization, the electric field is intense is parallel to that of the plane of incidence. You can call it as a parallel polarization. Here also there is a unit vector CNI bar and an angle of theta and theta, as same as the study in the E polarization or the perpendicular polarization. Okay, EI bar is equal to, now the change in the electric field and the magnetic field. There is a change in the electric field and the magnetic field. Previously, the electric field is EI into e power minus something. But magnetic field is EI e power minus j beta 1 and the cosine functions also. Okay. Now the reverse value here. The HI is equal to, now in this, the HI is perpendicular to that of the plane of incidence or parallel to that of the boundary condition. So HI is equal to, HI bar is equal to, actually, HI bar is equal to see in the diagram itself. Draw a perpendicular line here. So ANI bar is in this direction. So upward direction is a positive x direction. So theta I means opposite side is a sine theta I, and adjacent side is a cos theta I. So HI bar is equal to HI into, HI is a constant or magnitude, into sine theta I into AX bar. Sine theta I into AX bar. See, this is in the x direction. X is the positive and Z is a positive in these directions. So sine theta I into AX bar plus cos theta I into AZ bar. Okay. And now we know that eta is equal to the ratio between of electric to the magnetic. So I'm taking the EI by the HI. As in the medium 1, the EI and the HI, let us take the parameter is eta 1. So HI is equal to, what is the HI is equal to EI by eta 1. Okay, substitute here. HI bar is equal to EI by the eta 1 into sine theta I AX bar plus cos theta I into AZ bar. Got it, my students? So similarly, you can find the reflection also. HR is equal. So let us see whether the equation is what we wrote is right or wrong. See, HI is equal to EI by the eta 1 e power minus j beta. It is in the function after getting the x into sine theta I. ANI bar dot also we can apply here itself. Dot x into AX bar plus y into AY bar plus is R bar, my dear students. R bar dot is there. Z into AZ bar and also whole multiply with the AY bar. Now apply the dot product here. EI by the eta 1 multiplied with the AX is only with the AX only. Remaining two terms is a 0. So x into sine theta I, x into sine theta I plus, here also AZ is with AX is a 0, AZ with AY is a 0, AZ is only the 1. So Z into cos theta I, Z into cos theta I, AY bar. So HI bar is equal. Got it, my students? Now we got the same thing. HI bar is equal to EI by the eta 1 e power minus, you can take it as a e power minus j beta 1 into something. Okay, what it is, HI bar is equal to HI into e power minus j beta 1 into ANI bar dot R bar into AY bar. So we got the ANI bar is a sine theta AX bar, cos theta AZ bar, and R bar is a x into AX bar plus y into AY bar plus z into AZ bar. After the dot product, we got x sine theta I plus z cos theta I is a HI. Got it, my students? Then ER is equal to you can cross multiply or cross product, not the cross multiply, cross product here. A N R I bar is equal to, here the EI is here. Here it is AI. A N I cross AY bar or HI bar. Okay. Into eta 1 is there. HI bar means we already got the HI bar is equal to EI by the eta 1, EI the beta 1, e power minus j beta 1 into x sine theta I plus z cos theta I into AY bar is there. AY bar is cross multiply here with ANI. What is that ANI? We got ANI is equal to sine theta I into AX bar plus cos theta I into AY bar, not AY, ZZ bar. Apply the cross product here with AY bar. With AY bar. Got it, my students? So now you can see AX and AY. So ANI cross HI bar is there. Whenever you can get is a Z and Y is the reverse, or Y and the Z. You get Y and X is a minus and Y and Z. So in this the HI cross the value. HI cross ANI bar in the reverse order. So right here it is a AY bar cross HI cross AN bar. Previously we did in the electric field. HI cross AN. So A Y bar cross sine theta. So write down the AY bar cross AX. So order it is XYZ. The cross product of XY is XZ, AZ, YZ is AX, and ZX is AY. So Y and X is the reverse order. So sine theta I into minus AZ bar plus cos theta I into AY and AZ is in order, so it is an AX bar. See here, we got the same function. EI into already the EI, and it is multiplied with the eta 1 also. So eta 1 and eta 1 is get cancelled. EI into sine theta I minus AZ bar and cos theta I into AX bar, and whole multiply with this function e power minus j beta 1 x sine theta I plus z cos theta. So with this confusion we have HI cross or ANI cross HI. A little bit confusion. You go and observe the diagram itself here. What I told, draw a right angle triangle, and get, you see I am writing the drawing a right angle triangle here, like this. This is the starting point of the field, going upwards. Assume here the theta I is there. The theta I, opposite side is a sine theta I. Opposite side is a sine theta I, and adjacent side is a cos theta I. Okay. So this in the upward direction is a positive x, and backward direction is a negative z direction. Okay. Cos theta I into AX bar, sine theta into minus AZ. Well, this is a positive Z direction. Towards this direction is a negative Z direction. Got it, my students? Understood? If there is any confusion, we got HI cross ANI or ANI cross HI. To avoid that confusion, draw a right angle triangle here and directly write the expression and multiply the coefficient. Sin theta into minus AZ bar, cos theta into AX bar. Got it, my students? So now we got HI and the EI in vertical polarization. In vertical polarization, we got the EI is equal to and HI is equal to. Okay. Now, first of all, you can find the HR is equal to. What is a HR? HR is equal to. Let us take again HR is equal to HR bar is equal to HR into e power minus j beta 1 into, because this is in the medium 1 only, a n r bar dot r bar into a y bar. This is a formula here. That is HR bar is equal to HR bar in the reverse direction. So minus ER by the eta 1 into e power minus j beta 1. What is the ANR bar? Let's see the diagram and draw a right angle triangle here. Draw a right angle triangle. The theta is there. Opposite side we will get the sine theta. Adjacent side is a cos theta. So this is the starting point we have. It travels in the negative z direction. Cos theta r into cos theta r into AZ bar is a minus and sine theta r plus sine theta r into sine theta r into AX bar dot R bar. What is R bar? X into AX bar plus Y into AY bar plus Z into AZ bar. All are the equations only minus 2 into AY bar. Now in the power E minus ER by the eta 1 in the exponential power e power minus j beta 1 having AZ with AZ only. So minus Z cos theta R plus X into sine theta R into AY bar is HR bar is equal. HR bar is equal. Now let us see whether we are getting the same expression or not. HR bar is equal to HR bar is equal to minus ER by the eta 1 e power minus j beta X sine theta minus Z cos theta R into AY bar. The same coefficient we can apply here the AY bar cross ANR bar. Okay, to get ER bar is equal. ER bar is equal to ER into the coefficient AY cross ANR bar. What is the ANR bar here? Cos theta R into AZ bar and sin theta R into AX bar. So I am applying the cross product with AY and AZ. It's the same. So ER into multiplied with cos theta R into, already the minus is there, and with this minus term minus cos theta R into AZ with AY with AZ, not the AZ with AY. AY with AZ means AX bar. And plus sine theta R into AX and AY and AX. AY and AX is the reverse. So minus AZ and is a whole multiplying with e power minus j beta 1 and whatever we have get here x sine theta r plus, or the plus by students, minus z cos theta r. Okay. So here the minus is there. Here also the minus becomes a plus, and here also the minus becomes a plus. So ER is equal to ER bar is equal to see here the ER into cos theta r AX bar sine theta r into AZ bar and is multiplied with e power minus j beta 1 x sine theta r minus z cos theta r. So we got the HR and the ER. Previously we got the EI and the HI. Okay. In vertical polarization. Again, at the interface Z is equal to 0, the tangential component of electric field intensity must be the 0. Note that for a parallel polarization, the tangential component of electric field intensity in only X component, thus adding only the X components of electric field intensity in the equation 18 here, only the X components you can add. Only the X here, the e power EI into cos theta into AX bar, e power minus j beta 1 X into cos theta. Eliminate the Z components. Okay. Eliminate the Z component. And similarly, for ER also, ER is equal to ER into cos theta because it's the AX component. And Z component is eliminated. And here also the Z is a 0. E power minus j beta 1 x theta r is equal to 0. So bring the second term in the right hand side is a minus. EI is equal to ER is a minus and theta r is equal to theta r. Theta r is equal to theta r. To have the above equation valid for all the values of x, the conditions are ER is equal to minus EI and the theta r is equal to theta r. Okay. Now the total electric field intensity E1 bar in the medium one can be obtained by adding the two functions. E1 bar is equal to EI bar plus ER bar. Whatever the expression we got to add the two functions by changing what we have here, the ER is equal to minus EI and theta r is equal to theta. So ER is equal to ER bar is equal to ER as a minus EI and the theta r is changed as a theta. Then after you can add the terms, all it is in terms of the EI and the cos theta only. Simplify the function, E1 bar is equal to okay. Cos theta I is there. We got the J minus 2 by dividing the 2J here. When we write the sin x means sin x is equal to e power jx minus e power minus jx by 2z. Okay. But here, the negative sign for the positive exponential and the positive exponent, negative exponential having the positive. So take the minus 2 and the j is multiply and the divide here. Then it becomes of minus and this is a plus. So total term as sin beta 1 into z. Beta 1 z cos theta and already the cos theta is multiplied into ax bar. Okay. because both the functions e power minus j beta 1 x sine theta and e power minus j beta 1 x sine theta, the constant, not the constant, common term. And in the second term, minus vi, and this becomes a cos function because it's a plus here for the terms, by 2 and multiply the 2 here. Okay. So 2 is already common with the I here, sine theta I, and this total term is becomes cos beta 1 z into cos theta I a z bar. Here is a z bar is there. Okay. Similarly, the total magnetic field in the medium 1 can be obtained by adding the two magnetic fields. H1 bar is equal to Hi plus HR. H1 bar is equal to 2 theta I, and change all the functions. Theta I is equal to theta R is equal to theta, and ER is equal to minus ER. After simplifying, it is also becomes H1 bar is equal to 2 into eta EI by the eta 1 cos beta 1 z cos theta I, e power minus j beta 1 x sine theta into AY. So these two equations, what we got, the E1 bar and H1 bar. Following the conclusion can be drawn parallel polarization for oblique incidence. The x component of E1 bar is E1x and y component of H1 is H1y, representing the standing waves generated in z direction. Similarly to the previous case, the horizontal polarization, these standing wave patterns are recognized by the terms sine beta 1z and cos beta 1z. See here the cos beta 1z and sine beta 1z. Both the components E1z and H1y are in phase with the time and space in x direction. The velocity is a coefficient. What is the coefficient here? Sine theta I is there. So V1x is equal to V1 by the sine theta I. Similarly, the wavelength of wave in the same direction is lambda 1x is equal to lambda 1 by sine theta I. The wave propagation in x direction is a non-uniform plane wave. Non-uniform plane wave. Velocity with V1 by the sine theta I, and wavelength is lambda 1 by the sine theta or sine theta I function. Okay, my dear students. Then the oblique incidence at a plane of dielectric boundary. We completed oblique incidence at a plane of conducting boundary for vertical polarization and horizontal polarization. Then we go for oblique incidence at a plane of dielectric boundary for horizontal and vertical. What is a horizontal? Horizontal polarization is also called as a perpendicular polarization, is also called as a E-polarization. Vertical polarization is a parallel polarization since for incident beam, electric field is parallel in the vertical, electric field is perpendicular in the perpendicular polarization. So both are comparing with electric field only. So the name becomes a perpendicular polarization of E polarization, parallel polarization of H polarization. Okay, and we can see another two is there, oblique incidence at a plane of dielectric boundary. One is vertical polarization, other one is a horizontal polarization also. But in the dielectric boundary, there is a transmission is also there. Previously, what we discussed here, the vertical and the horizontal polarization of a plane of conducting boundary, there is no any transmission. E1 bar is equal to EI and ER only. HI bar is equal to HI plus HR only. But there is no HT. We consider as Z is equal to 0. When the Z is equal to 0, then only we got the Snell's law of reflection. Theta I is equal to theta. But in this boundary condition, there is a Transmission is also there because the dielectric, the conductivity is not very less, and intrinsic impedance is not the zero. Understood, my student?